All right, so now I'm going to show you how we're going to finish up this problem for the center to center dimensions. So we already know that the diagonal is 4 feet 4 and 5/16 inches from the previous video, but now we need to figure out what this vertical change is between pipe A and pipe F, and then between pipe D and pipe C, because there is a vertical change happening here. You can see this little triangle right here is how we can figure out what this vertical change is. So how we can figure that out is just like we took a line going straight from one pipe to the other pipe right here, we can do the same thing here. So going straight from one pipe to the other pipe, we can see that just like this is a 45-degree angle, that angle offset that is happening right here is also 45 degrees. Now, these two elbows are taking that angle and they're cutting it exactly in half. So even though I have an offset of 45 degrees, this triangle is always going to be exactly half that. So in this case, that's 22.5. And then we want to solve for my vertical change right here. So in this triangle, this is my opposite, adjacent, and hypotenuse. And we already know the adjacent is going to be the distance between the pipes, which is 9 inches. And we're trying to find the opposite. So that tells me I'm going to use tangent. So I'm going to use the tangent of 22.5 is equal to my opposite, which is my unknown, divided by my adjacent, which is 9 inches. And then we would multiply both sides by 9 inches. So 9 inches times the tangent of 22.5. All right, and we get 3 3/4 is this vertical change. Now, we could also have done this using the pipe trades functions. So 9 inches is my run, and I want to find my offset, and I know my angle is 22.5. I would do 22.5 is my angle, and then 9 inches is my run. Then my offset is 3 3/4 inches. So that's just another reminder of a different way we can find this. The other way we can do is using the constant 0.414. And the constant 0.414 just comes from this value right here. It's the tangent of 22.5 is 0.414. So when we're in this big 45-degree offset, the constant we use to find the diagonal is 1.414. And the constant we use to find this little vertical change right here is 0.414. And if I take that 9 inches again, and I multiply times 0.414, I should get 3 3/4. So we should get the same answer no matter how we do it. Now the only thing we have to do now is take our vertical distances and either add or subtract the 3 3/4. So A here is 2 feet 10 inches, and F is going to be 2 feet 10 inches plus 3 3/4 inches. So we're just going to do 2 feet 10 inches plus, sorry, I got glare on my calculator here, plus 3 inches and 3/4. And that gives me 3 feet 1 inch and 3/4, which is the length I have down here. All right, so that gives me A and F. Now to find C, we want to use this vertical distance here. Now the biggest mistake that people make is they want to subtract the diagonal. They think, oh, the length of this pipe here is 9 feet, but that's not true. The length or the height of the ceiling or whatever you're working with from the base to the top is 9 feet. So it's going to be this 2 feet 10 inches and then this vertical 3 feet 1 inch. So if I want to find C, I'm going to take the total, which is 9 feet, and then I'm going to subtract these two vertical distances. So we're going to subtract 2 feet 10 inches, and then we're going to subtract 3 feet 1 inches equals, and we get that C is 3 feet 1 inches. All right, and then from here, C is longer than D, so that vertical change of 3 3/4, that's going to be what we subtract from C to find D. So since C is longer, we're going to do that 3 feet 1 inch minus 3 3/4 inches. And we get that D is 2 feet 9 1/4 inches. So basically, we can use these little distances to find the difference between the pipes that are right next to each other, and then we can use that big vertical distance to find the remaining pieces of the pipe.